Now what we're starting today is quadratics, quadratic functions. Now we've looked at quadratics already. Last chapter was quadratics. We had it in standard form, ax squared plus bx plus c. So what we're doing in this chapter is purely going to be focusing on those quadratics. Now the formulas we had from last chapter, the y equals 1 over 4p times x minus h squared plus k, will not show back up. We're not dealing with that formula again, but we're dealing with those type of functions. Now the first thing we're going to cover is factoring. And we're going to look at one of these two here, kind of doing the opposite of factoring, our distributive property, because what we're going to be doing today is the opposite of it. We're going to be doing the opposite of it. So if we looked at, say, this first one here, and I distributed, well, we do 4x times x. We multiply through everything that's inside the parentheses. And 4x times x would give me 4x squared. So we do this multiplication first, and then we do 4x times negative 3. Well, 4 times negative 3 is negative 12x. And once we finish doing that, we move on to the next one, negative 5. Negative 5 times x is going to be negative 5x. And negative 5 times negative 3. A negative times a negative would give me a plus 15. We have to combine like terms. Negative 12 minus 5x is negative 17x plus 15. Because since it's x and x, we can combine negative 12x and negative 5x because they are like terms.
No, I did it wrong.
Now, one thing I want to point out with this, the middle term, the term with just x, comes from what? When we multiply 4x and negative 3 and negative 5 and x. Yes, that's where the middle term comes from. So I'm pointing this out. It's going to come back in a little bit, but this is where it comes from, is that middle term. So we're not going to worry about simplifying this, because it ends up working out to be a squared plus 2ab plus b squared, but we're not worried about that. We're going to be factoring these. Ax squared plus bx plus c. So this should be the top of the second page. Top of the second page. Previously, you factored this where a was 1 to factor this. So the main thing is when we factor anything, the main first step is we need to see if there's a greatest common factor. If there's a greatest common factor between any three terms, we do that first. And then we're going to go through the rest of the steps. So I'm going to list the steps out here on the first one. And I'm going to write them down here on the board so we have them up here also. But when we look at this here, our first main step when factoring is greatest common factor, GCF. Whenever we're factoring any of these here, the first thing you need to really look for is the greatest common factor. Because if there is a greatest common factor between our three terms, we factor it out. So looking at this here, is there a greatest common factor? So is there a number that is divisible by all three terms? 5. So the greatest common factor, a number that goes into all three of these, is 5. So what we're going to do is I'm going to have 5 parentheses. Because we're factoring it out. We're pulling it out. We're dividing it out of each term. So what is 5x squared divided by 5? X squared, because the 5 and 5 would simplify to 1, yes? 5 over 5 would simplify to 1. So we're left with x squared. What about 5 divided out of 15? 3x, yes. Because 15 divided by 5 would give me 3, and I have x. And lastly, 5 divided out of 10. 10 divided by 5 is 2. There will not always be a greatest common factor. There will not always be a greatest common factor, but if there is, we factor it out. We factor it out first because it's going to make factoring easier if there's not a greatest common factor. Now the second step is to write two sets of parentheses. And what that's going to look like is, we can say with 3 spaces. Because what we're going to have is when we factor, if it's factorable, each one of those parentheses, because we're going to have 2 of them multiplied together, kind of like how we had at the start, the one that we simplified, we're going back to that. We're going to 2 sets of parentheses. And if we think about that, there was 3 things in each one. We had a number, a sign, and a number. We had a number, sign, number in both of them, yes? That's why I write the 3 lines, because it's to keep track of it. Step 2. Okay, we've followed along so far, yes? So we did step 2. Step 3. Find the signs. We need to find the signs. We need to find the signs. Okay? I'm going to add a new page here, so if you go back and watch it, you can get this down because it's not going to fit on the page. Okay? Part of step 3. If the sign of the constant term is positive, the signs inside the parentheses are the same, and they match the middle term. If the constant is positive, the signs are the same and they match the sign of the middle term. Probably got you worried if it's negative. If the constant term is negative, the signs are opposite. If the constant term is negative, the signs are opposite. So those are our 2 main cases. If the signs are the same, if the constant term is positive, the signs are the same and they match the sign of the middle term. If the constant term is negative, the signs are opposite. You're probably wondering what the constant term is, yes? The constant term is the number without a variable. And that's going to, any math that you do at all, when they talk about polynomial functions, these here that have a variable x, x squared, x cubed, any variable y, z, the term without a number, or sorry, the number without a variable is constant. It's a constant term. When we talk about numbers without a variable, they are considered the constant in functions. When we talk about functions, a number without a variable is the constant term. So when we look at this here, x squared plus 3x plus 2, we're not worried about the 5 because we're factoring this here. We're factoring this here. This here, the 5 is what we call a scalar. It's increasing the values of the function. Not changing its intercepts, but it's just increasing all the other values. So we're not worried about the 5. So looking at this here with x squared plus 3x plus 2, what is the constant term? 2. Is 2 positive or negative? It's a positive number, yes? So what are our signs? The signs are the same and they match the sign of the middle term. Okay, now what are we talking about? We're talking about the signs that are going to go inside these parentheses. Because each one of these parentheses is going to have a sign. Because as we saw in the first one, they were both minus, yes? So we could have two negatives. We could have two positives. I can have a positive and a negative, or a negative and a positive. We can have one of these setups. So what this step does that we just did here, and I wrote down, lets us know what the signs are. I'm going to come back here. How did we get 15 for this here? We did what? Negative 3 and negative 5, yes? A negative and a negative will make a, what other setup, what other signs would give me a positive number? A positive and a positive, yes? So if it is a positive number, either the two things that multiplied together were both positive or they were both negative. It's one of the two, yes? So that's why we have this here. If the sign of the constant term is positive, the numbers have to have the same sign, because either they're both negative or they're both positive. Now let's go back here. So these were both negative, yes? What is the sign of the middle terms before we combine them? They're both negative, yes? So the sign of the middle term is negative when we finish, yes? So if this is positive and this is positive, that means our signs have to both be positive. Because as we saw with the two negatives, if they're both negative, when they multiply, they become positive. But when we combine them, those two middle terms, it keeps its sign. So if it's positive, we look at the middle one to see, they both positive? Were they both positive? Or are they both negative? And here, because I have a positive and a positive, these signs have to be positive. And that's it for signs. Now that brings us to step number 4. Find the factors of the first and third term. So what we're going to do next is find the factors of the first and third term. I'll go on and give you step 5. Plug and check. Step 5 is plug and check. Plug and check. And plug and check, step 5 is going to make more sense here in a minute. Step 5 is going to make more sense here in a minute. So we have all those steps. So if any of this, so not step 4 and 5, but any of the steps we've done so far, is everything making sense? Yep. Okay. So let's look at the factors. I'm going to have to erase this here. So first and third term. Well, what is the first term? X squared, yes? Yeah. I'm going to put x in for both of them because there's no other way for me to get x squared. X squared is just x times x. Yes? There's no other way to write that. So if there's one set of factors, I just plug them in. I just plug them in. So what about the factors for 2? 1 times 2, yes? Okay, I'm just going to plug those in. Whenever there's one set of factors, I just plug them in. It doesn't matter how I set them up, because we'll take care of that here in a minute. So any questions on this here? Because x and x, we just plug it in. 1 and 2, we just plug it in. So let's see. So once we get these plugged in, we do the factors of the first and second, yes? So before we do the next step, let's look back at the previous one. Where did I get 17? Because I got negative 12 from 4x times negative 3, yes? And I got negative 5 from negative 5x times x, which gave me this here, yes? So we got the middle term from the 4x, so from the outer two, 4x times negative 3, and the inner, negative 5 times x. That's where the middle term comes from, yes? We got the first and last term from 4x times x and negative 5 times 3, yes? Okay. So looking at this here, if I did the first ones, x and x, will I get x squared? Well, yes. Because how did I know it was x and x? Because I factored it from x squared, yes? Where did I get 1 and 2? I factored it from 2. So when I multiply, if I multiply these, or these, will I always get back to this and this? Yeah, that's always going to be the same because I factored it from those two. Those are the factors of those two numbers, yes? Now, when we do this here, move these out of the way. The ones that we're really concerned about are here and here because these are the ones that give us the middle term. Here where we want to get 3, yes? This is where we check. That's where this plug and check comes into play. Here, it's not going to make that big of a difference because how many factors did we have of the first term? 1. How many factors do we have of the third term? 1. And they're both positive. There's only one real way to set this one up. It won't always work this way. So what we do, and we'll see this when we come into play here in a minute, is we check it. I check x times 2 is plus equals, is that what we had in the middle? That is factored. Now we could have gone and multiplied through, done x times x. X times 2, 1 times x, 1 times 2, and gotten x squared plus 3x plus 2. But we do know that x times x will get us back to x squared, yes? 1 times 2 will get us back to 2. So I don't have to do those. I can just check the outer and inner to make sure that I get back to the middle term. Because the middle term is going to be the one that would be changing. The outer two, x squared and here 2, they shouldn't because the way we got those was from factoring it. Those are the factors of it. So we should get back to that every single time. The first and last term, when factoring, as long as you get the correct factors, will always come back out. It's the middle one that changes. Any questions on this here?
We are ready for any seniors that in town and apply for college through the day today. Thank you.
Okay, so let's look at this one here, this next example. So what's our first main step? Is there a greatest common factor? 4. We should know at least 2 because looking across these, well, 2, they're all even, yes? So we have at least 2. And it does work out that it's 4. 4 is the biggest one. So 4 out of 4x squared would give me x squared. 32 divided by 4. And if you have trouble with doing those, you can divide each one. So I can type in the calculator 4 divided by 4. It's 1, so I just have x squared. 32 divided by 4, it gives me 8, so I have 8x. 60 divided by 4 is 15. So that's step 1. Factor out the greatest common factor. Step 2 is what? 2 sets of parentheses with 3 spaces. So I'm going to have 4 parentheses. 1, 2, 3. So why would you say that? Since the constant term is positive, the signs are the same and they match the sign of the middle term, which is positive and positive. Positive and positive. Now we need the factors of the first term and the constant term, or the third term. Yep, so the first term is just x and x. For most all of these quadratics, when we're talking about quadratics, it's going to work out it's x and x. Now there might be a number with it. There might be a number in front of it, because we could have, say, 2x. So we'll have numbers in front. But it'll always have x and x in the first term. So factors of 15. 3 and 5 is 1. We also have another one. What? 1 times 15. Okay. 3 goes first or 5 goes first? Doesn't matter. This is where I say plug in check. Because when we plug in check, I'm saying, okay, we want 3 and 5. So I just picked those. And now we check. So we do x times 5, which does give us 5x. So in doing this here, I wouldn't get so caught up on which one do I want to try first. I just pick one. And the more that you do these, the easier it'll be to see which ones are more likely going to work, okay? Because no matter which ones I pick, I'm always going to check it. I'm always going to check to see if it works. And here, since it did work, those are the factors. Because I worked this out so that it'd be easier. Because without step number 3, the way we would look at the factors, if it was negative like the first one, we have to consider all the signs. So let's say that we had negative 15 as the constant term. If we did not have that step 3 with the sign check, our factors would be negative 1 times 15 and 1 times negative 15, or negative 3 times 5, or 3 times negative 5. So I have 4 different factors, yes? But if we do step number 3, because it's a negative constant term, the signs are opposite, yes? It's just those two, because the signs are taken care of. We don't have to worry about signs. And one important thing I will say with this here, for all these steps, because it's working with ax squared plus bx plus c, a is positive. And I'll show you how we can make a positive when we get to that point. A is positive. The number in front of x squared is positive for this to work, okay? And it's not a hard fix. Because what can I multiply by something to make it positive if it's negative? Negative 1. Because negative 1 does not change the values, it just changes the sign. It's an easy fix. Any questions on any of these here? You good with these here so far? Okay, let's look at this one here. First step is, do we have a greatest common factor? No. We do not. We do not have a greatest common factor. So we move on to step 2, which is 2 sets of parentheses with 3 spaces. So we just move on to step 2. If there's not a greatest common factor, we move on to step 2. It is our sign. So we look at the sign of the constant term, and the constant term is positive. So we look at the middle term, which is, so the signs would both be positive. When the constant term is positive, the signs are the same and they match the sign of the middle term. 4x and 3, well, we'll still have x and x, because that's the only way we can get x squared, yes? So we have 1 times 4 and 2 times 2, yes? So what is 3? Third term. 1 and 3. So I just picked 1 and 3. Doesn't matter which, I'm just throwing them in, yes? So let's do a consensus. What do y'all think? 2 and 2 or 1 and 4?
It shouldn't matter, should it?
Well, one of them will. Which one do we want to try first?
I would say 2 and 2.
1 is 4.
Okay, I'll do 1 and 4. Let's just try it. So 1 and 4. It doesn't matter.
Equal part there.
It's equal. I'm just going to pick one. Because what is our last step? Plug and check. So no matter what we do, I'm just going to throw them in. I'm just throwing them into there, because when we check, it'll tell me either yes, it's correct, or no, it's not. So let's multiply, because we're going to do these 2 times these 2. X times 3 is 4x is that what we wanted? No. So I'm going to try flipping it. I just flipped it. Because this didn't work. So 4x times 3 is x. 1 times x is that what we wanted? We're done. Now, if that hadn't worked, I would have moved on to 2 and 2. Because we can't really change 1 and 3, because there's only one set of factors, yes? And by flipping, when I flipped the 1 and 4, I essentially was the same as changing 1 and 3. So I changed one of them to see if I get a different answer. So what I normally do is I try one of the first terms because it changes, flip it. If that doesn't work, we try another combination. And we keep trying combinations until we find the one that works. And when we find the one that works, we're done. Those are the factors. Questions on this here? Let's look at this next one. So looking at this one here, is there a greatest common factor? Well, no. So we move on to step 2. Bless you. 2 sets of parentheses with 3 spaces. So, what do we look at? We look at the sign of the constant term, the term without a variable. And is it positive or negative? Positive. If the constant term is positive, the signs are the same and they match the sign of the middle term. What's the sign of the middle term? So our signs would be negative and negative. They're both going to be negative. Because if the constant term is positive, the signs are the same and they match the sign of the middle term. Well, 3 and 2. And what are we going to we're going to have here? X and x. Because that's the only way we get x squared is with x and x. So what are our factors of 3? Any others? No, 1 and 3. I'll just plug them in. How about 2? I'm just throwing them down. Because what is our next step? We We check. X times negative 2. X. Negative 1 times 3x. Which is negative 5x. Is that what we wanted? Okay, what do we want to switch? No. Because for this setup, switching 3 and 1, the 3x and 1x, would be the same as switching 1 and 2. So we just need to switch one of them. Now 3x times negative 2 would be negative 6x. Negative 1 times x is negative x. Negative 7x. That's it. That's it. Questions on this here? Questions on anything we've done here? So a lot of this is what? Plug and check. Plug and check. As we get it set up, find the factors, then plug and check until we find the right one. Questions on this here? Let's look at another one because I think we have a few left. Let's look at this one here. This will be the last one we do today. Is there a greatest common factor? No. There's a greatest common factor between the first and third term, but there's not one with the middle. There's not one with all three. So we do move on to step 2. Since the constant term is positive, the signs are the same and they match the sign of the middle term. Since the constant term is positive, the signs are the same and they match the sign of the middle term. So x and x, yeah. Because the factors of 2 are 1 and 2, yes? So I'm going to plug down 2x and x. We'll put those down. Now, what are the factors of 6? And that's it. So what would we use, 1 and 6 or 2 and 3? So 2x times 6, 12x. 1 times x equals 13x. That's not correct, yes? I can't switch these. Because if I switch these, I'm just going to write it out so you guys can see it. If I switch, I'm just going to switch the 1 and 6. 2x and 6, do they have a common factor? Yes? Did the original one have a common factor? So if the original one, what we're factoring, did not have a greatest common factor, neither one of these sets of parentheses will. Because if there's not one to begin with, there can't be one in either set of parentheses. So that means 2 and 6, 2x and 6 cannot be in the same set of parentheses. So if we flip it, we'll have the same one that we just did. Does that make sense? Okay, so we move on to the other one, 2 and 3. So this one here has to be 3, and this one has to be 2. Two x times 2 is 3 times x is plus, which is what we wanted. There is not a rule in any math book that says if there's not a greatest common factor to begin with, then there won't be one of the sets of parentheses. It's just something we come along with. So the more that we do these, and the more that y'all do these, the more that you're going to pick up on the patterns and how these work. Just because you've done them, you're seeing them, you're picking up on it. So with these here, the biggest thing is practice with these, okay?